Okay, we're going to do a couple more examples on solving systems of linear equations by substitution. Okay, here's example 3. We have two equations, both with x and y, and our first step is to choose one of the rows and get one of the variables by itself. Well, you can see all the coefficients of the variables are all numbers other than 1. They're all integers other than 1. So there's not really any good choice here that's any better than the other. Let's just choose the top row. And let's get x by itself. Okay, so it's just a preference, not really anything particular that tells us to do that. We could choose the bottom row. Okay, so let's write the 4x minus 3y equals 7, and let's get x by itself. Now, the only benefit of getting x by itself and not y is that if we get y by itself, we have to divide by a negative 3. So I would choose the variable that's positive, that has a positive coefficient. That would be the x. Okay, so if we're going to get the x by itself, what do we need to do to get the x by itself? Right, we need to get rid of this minus 3y. So add 3y to both sides. Okay, so these 3y's cancel, we're just left with 4x. And then 7 plus 3y, well, they're not like terms, so you can just write 7 plus 3y. So 4x equals 3y plus 7, or 7 plus 3y. It doesn't make a difference how you write it. Okay, one more step to get the x by itself. We need to divide by 4. Now, you could divide by 4 on all three of the terms separately, but I think it might be easier to just divide by 4, writing the right-hand side as one fraction. So just write the 4 underneath this whole right-hand side. These 4's cancel. So x is equal to 3y plus 7 all over 4. Okay? So we just divided by 4 and wrote that 4 underneath the whole fraction. Okay, now we need to write down the other equation. Which row is the other equation? This bottom row. We're going to replace the x with 3y plus 7 over 4. So this x is replaced with the right-hand side of this equation. And then bring down the minus 2y and the equals 6. Okay. Now this 3 is really 3 over 1, so we could distribute this 3 to the numerator. So 3 times 3y, that'll be 9y, and then 3 times 7, 21, all over 4. And then bring down the minus 2y equals 6. So we have an equation that has fractions. We want to get rid of this 4. So we could do that by multiplying each term, or each fraction, by the LCD, which is 4. So multiply this one by 4, this 2y by 4, and the 6 by 4. Now over here, we don't have to distribute the 4, because what's going to happen is they're going to reduce. We can line out these 4's. Okay, so bring down the 9y plus 21, multiply the 2y times 4, don't forget this minus sign, and the 6 times 4. Okay, so 9y plus 21 minus 8y equals 24. Add the like terms and get the letter or the variable by itself. 9y minus 8y is 1y, or just y. Then subtract 21 by itself. So, sorry, Subtract 21 from both sides. So y is equal to 3. We have the y, so we need to find out what x is. So we're going to take that y and replace it with 3 over here on that right-hand side. So that gives us 9 plus 7, 16 over 4, which is equal to 4. So we have our answer 4, 3. Okay. Especially if this was a test, you would definitely want to check your answer. Go back to the 2 original rows, replace x with 4 and y with 3, and they should both work out. And if they don't work out, that would mean that you made a mistake, and we need to fix that mistake. Not a problem. Alright, let's do one more example. You may want to pause and try to work this one out on your own. Otherwise, we'll get started. Alright, so let's see. Which row should we get a variable by itself? Let's take the top row. And again, let's get x by itself. So if we're going to get x by itself, subtract 8y on both sides. Okay, again, it doesn't matter which row you chose, the top row or the bottom row. Doesn't matter if you got y by itself or x by itself. It's just a preference. It'll work out either way. So I'm just choosing to get the x by itself in the top row. No real reason. Alright, so negative 51 minus 8y, or you could write the negative 8y first. Does not matter. And then we're going to divide by 5 to get the x by itself. And again, just leave it as one fraction here. So x equals negative 8y minus 51 all over 5. Okay, so now let's write down the other row, which is the bottom row. And we're going to replace the x with this right-hand side that I have here in blue. Negative 8y minus 51 all over 5 is going to get replaced or substituted where the x is. So bring down the 2 and then replace the x with this right-hand side and then recopy the rest of the equation. Now distribute the 2 in the numerator. Two times negative 8y, negative 16y, and 2 times negative 51 is negative 102 over 5. Remember, there's a 1 below this 2, so 1 times 5 is just 5. And now how do we get rid of this fraction? Right, multiply each of these fractions by 5. So you just put a 5 here in the numerator here. After this 3y, and after this 20. So just write it. Now what happens with these two 5s? Sometimes people try to distribute this 5 all the way through, but there's no reason to, because they line out. Bring down the numerator, multiply the remaining terms here. So 3y times 5 was 15y, and negative 20 times 5 is negative 100. Add like terms and get the variable by itself. So a negative 16y and a positive 15y is negative 1y, or just negative y. Bring down the negative 102. Add 102 to both sides. Now don't forget about this negative. A lot of times people forget about the negative in front of it, but not you. So divide by -1 to get the y by itself. So y is equal to -2. Almost there. We have the y value. We need x. You could go back to one of these originals and substitute. You use either row, top row or bottom row. Substitute the y with -2 and solve for x. But this is so much easier because x is already by itself. So replace this y with -2 in this fraction. Now -8 times -2, that's 16. 16 minus 51. So really we've got to subtract 16 from 51. And that'll be a -35 over 5, which is equal to -7. So our x is -7 and our y is -2. So that's our solution set. -7, -2. And you should do the check. Again, go to each of these rows, replace the x with -7 and the y with -2, and you should get the same value on each side. That would verify that this is the solution. Okay, I'll see you here for the next video.